So our first guest today is Peter Simon. He works at Electronic Arts, specifically on EA Sports titles, and he's going to be talking about how QA engineering works at a AAA company. So Peter, the room is yours.
Thanks. Hello, everyone. Um, Thanks for having me. Let's jump into it. As Ryan mentioned, I work at EA Sports. I've been there since October 2012, so I've worked on a couple games since then, all within sports. So in Orlando, where I live, the studio there works mostly on Madden and college football, but my organization's within sports, and so that also produces other games like FC, NHL, UFC. Um, we've worked on other games in the past, like the golf games and NBA Live as well. A couple games. So jumping into it, so I want to share with you kind of how I got there. Um, so I went to UD 2010. I doubled majored in computer science and business leadership. It's kind of a unique double major because a lot of times with computer science, you get people that are just kind of majoring in computer science and business or just people in business. So I kind of got to experience both worlds. My mindset with that going in was that I did want to try to get into the video game industry. I knew it was hard. At the time, I wasn't all in on programming. It's programming is not for everyone, and it's definitely tricky at the beginning when you're learning how to code because it's very overwhelming having to research so many things and having to learn the programming language to know how things are. I did a little bit of programming in high school, but I knew going into it that I wasn't going to be the best coder. There was a lot of other um, classmates that I had that had a lot of side projects where they made their own websites and did their own things. I didn't really have big side projects in college. And so I thought that having this double major would help me, set me apart from other um, students, would help make me more well-rounded and could potentially make it so if I did get a job in programming, I could potentially pivot out of that job eventually in the future if I didn't like programming as much. Um, I took extra classes over the summer and had a full, I think it was like 17 or 18 credit hours every semester to get it all done within 4 years. Um, Throughout my time at Dayton, I had a number of internships, which I highly recommend having internships while you're at Dayton. Um, for all of mine, I got from the career fair. So if that's still going on, I definitely would recommend that, where just bringing your resume to the career fair, going to the career fair, going to all the booths. For all of these jobs, I believe I got it from giving them my resume and then kind of getting a call back for an interview after the career fair. Um, so for these roles, so my first role was in at NCR, which at the time the headquarters was still in Dayton. My senior year, they actually announced that they were moving their headquarters from Dayton to Atlanta. And so I worked there for a year, part-time during the year, and then also during the summer before junior year. That was more in a QA role, so that was kind of um, testing the software they have, which NCR they work on ATMs and ATM software, so kind of testing ATM software to make sure that it doesn't give you the wrong amount of money or something. So I did some of that, and that was nice because I wasn't the best programmer, but I was very hardworking and I got pretty good grades. And so QA I thought was a good starting role for me just to get my foot in the door and my foot in the door in the software development industry. Um, I was going to return to NCR, but after they announced that they were moving, there was kind of, they weren't doing a lot of like hiring. They're kind of ramping down operations in Dayton to ramp up their operations in Atlanta. So it challenged me to find another role. And so that's where I applied to Smuckers and got a role at Smuckers. That's located in Orrville, Ohio. So kind of in the middle of nowhere. And that was just for one summer, but before senior year. So it was nice to jump to another company, kind of learn from there. For that role, I was doing some QA, but also some software engineering as well. So um, within my classes at Dayton, I learned, some C++ plus plus and some programming. But at QBase, I learned a little bit or at Smuckers, I learned a little bit of Oracle and a little bit of other scripting. Because Smuckers was located in a different city, I couldn't work there during my senior year. So I looked for another job during my senior year to work part-time while I took classes. And so that's where I found a job called QBase, which is in Springfield, Ohio. So maybe 20 or 30 minutes away from Dayton, but I could just drive there. QBase was good. I had a QA slash SE role, so kind of testing things and also kind of writing um, tools to help with testing. And then that kind of started my path towards quality engineering, which I'll go into a bit more. But after I graduated from Dayton, I got a job at London Computer Systems. That's at Cincinnati, Ohio. Um, I worked there for 14 months after graduation, and that one was pure software engineering. For there, I did a lot of prototyping, so working on kind of not their main bread and butter product that was used, but kind of the next iteration of the product that they wanted to work on for many years before they released to the product. And so there, we worked with .NET Framework, C Sharp, WPF, these different tools. It was kind of a GUI application that allowed scheduling um, and managing rent. So like people that owned apartment complexes would use this software to help manage their tenants and stuff. And so I worked on that software for a little over a year. Um, One thing with all my roles, so like a lot of people probably they just get one internship. So for me, I was kind of happy to jump around different companies because it helped me understand a lot of different things. Like NCR was a big company, QBase was a very small company. So I kind of got to see what I liked. And also QBase was doing a bit of government contracts. Um, LCS and NCR were kind of more private companies that just, created software and then kind of sold it to people. And so kind of different ways and different mindsets of the people that work there. And so it was definitely fun to kind of see all of these different companies. I knew for each of these roles that I kind of treated them as kind of a stepping stone, trying to advance myself with each role. So each role was trying to do more complex software engineering, trying to get out of the QA role into the the pure SE role, which um, SE roles kind of have a higher demand and higher complexity than QA roles. And so um, after I graduated or after I had my time at LCS, I knew I wasn't going to spend my entire career there. I kind of just wanted to build up my resume at that company. I knew I wanted to kind of figure out how to make my way into a video game company eventually. So after LCS, I went to grad school at Full Sail University. It's a little school in Orlando, Florida, that is kind of a media school. So people use it to try to get into the video game industry, to get into the movie making industry, other things. It was a bit of a risk going there, um, which really like for that school and schools like that in general, there's a couple other schools like um, small media schools like that and other West Coast cities like LA, San Francisco, Seattle. A lot of times um, you want to kind of go to a school that's next to where there are existing game companies if you're trying to get into game companies. And so in Orlando, there was maybe two or three game companies at the time there, but a lot of game companies are more in Los Angeles, San Francisco, and Seattle. Um, and so I knew I had to be flexible with moving. There's not really a lot of game companies in Ohio. And so, I kind of needed to move to kind of make myself a better candidate for that degree at Full Sail, it wasn't really in programming. They called it game design, but it was more related to project management. So that is more managerial, time tracking, and task tracking with a video game industry emphasis. It was a 1 year degree that got me a master's, but it was kind of a full-time degree where it was, I wouldn't say maybe 40 hours a week in the classroom, but it was maybe probably over 30. And so it was a lot of classes in a 1 year period to get the master's. And then after Full Sail is when I got the job at EA, which the EA studios in Orlando, and that's where I live now. The University of Central Florida, I got while working at EA, kind of an extension of that business leadership undergrad. I always kind of wanted to get an MBA. I figured it'd help further round me out. I started getting the MBA. That was like a 3 or 4 year part-time thing I did while working full-time at EA. Just because at the time at my start of EA, I wasn't sure if I really wanted to be all in on software engineering. And so just getting an MBA would help further round me out and help kind of bring me more perspective to a lot of the other engineers that I worked there. So now I'm going to go into a bit more of software engineering at EA and quality engineering, which is specifically what my job is in. I got hired onto um, the quality engineering role as my first role in EA. So after graduation of Full Sail, I didn't immediately get the job. So because the program was a full-time job, because the master's program was a full-time operation, it was kind of hard to be looking for jobs while finishing school. And so it took me about 3 months after I graduated to get the job. Um, and it was definitely hard. It was a hard 3 months, like not having a job and not being in school and looking um, for a job. I basically spent 8 hours a day, looking on websites of all these different game companies across the states, across the United States, and kind of, seeing if there was new job listings posted and applying to everything that made sense. Things that were in project management, things that were in software engineering, things that were in data analyst roles, just because I had a little bit of database experience as well. I've had in those 3 months, I've had probably five or so phone interviews with game companies, but EA was the first offer that I had, and so I was definitely excited to get that offer and to take that offer. Um, I think, because that offer was in quality engineering, I think my background in testing actually helped me get that job. Like they saw my background and all my internships where I was doing some software engineering and some testing, and they wanted a person that kind of had that experience. And so I think it definitely did help me. Within EA, we have these, software engineer one, software engineer two, software engineer three. So kind of these different levels of software engineering. I currently work as a software engineer three. Um, I work on a central team that assists multiple titles. So kind of for these game companies, a lot of times you either work like some people work only on Madden and some people work on like American football. So they work on stuff that helps Madden and college football. And some people work on even more central tech that it's used by multiple teams. And so for my role, it's central sports. And so that's how I was able to build up so many credits in games is because I work on a central team that assists multiple titles. I work on developing tools to help reduce the number of bugs in the game. So quality engineering is building tools to um, help people find bugs, help people fix bugs. A lot of times they have different groups of teams. There's the graphics team, there's the gameplay team, there's the stability team. And so a lot of the tools that I work on help the stability team to help make sure that the game is stable throughout the entire development and even after the game ships when they're releasing patches to try to lower the crash rate, lower the amount of just weird bugs or glitches in the game. At EA, we use a lot of programming languages. Game code is in C++, but a lot of times tools, at least within my organization, we kind of have a lot of flexibility to work in whatever programming language that we like. I definitely like .NET and C Sharp for database, MS SQL, Microsoft SQL Server, and then for front end, I've done a lot of things like jQuery, kind of more so where we've been using Angular for front end web page development. Um, but I have worked in things like Java, Groovy, MySQL, Elasticsearch. So I've worked on a lot of different things, um, but a lot of tools recently are in those things that I listed on the slide. With software engineering and the game industry in general, there's a lot of variety. So games are always changing. They're adding new features, new modes. The platforms are always changing. So when I first started, it was kind of the end of PS2 days, kind of the middle of PS3 days. And so PS3 and then PS4 and now PS5, there's just a lot of the ways that we interact with those consoles are different from a tools perspective. And so like the way that you reboot it programmatically kind of changed between PS3 and PS4. And similarly for Xbox, through all the console generations. Um, in addition, over the years, like we change as well. Like for people using the tools, after using the same tools for a number of times, we get a more mature, more advanced ideas and say, like we want more complicated workflows to kind of, kind of from working with experience, we know better ways on how to be more efficient with finding bugs than when we first developed these tools a long time ago. And even things like AI and ML kind of changed what's possible. And so, um, there's always it's like we have an infinite amount of work to do at these companies because there's always so much changing, and we're always trying to keep up with everything. So within EA, there's a lot of different tools. So you probably heard me say tools a lot now. So now I'm going to try to give some examples on what actual tools there are. Obviously, when people think of game development, like they know that the game is a big piece of software, but there's a lot of software to help with that game development. One example is game client automation. That is where you have some kind of script that makes the game play itself. And so, like for example, a game script for Madden will load up Madden. It will go into like the play now game mode, and then it will have the game play itself. Kind of like when you do CPU versus CPU in Madden, the game will just play itself. Um, so we do that to avoid someone manually having to play the game. So obviously, we still do have a lot of manual people playing the game, but using automation will help supplement that at a lower cost. So you don't have to have like hire a person to test this thing. You can try to get this game script to test the game itself. Um, Not only is there logic to get the game to navigate itself, but there's also logic to get the build to get the game build on the hardware, so on the dev kit, the test kit, and to set up that kit in a good state to run that automation. And then when it's running the automation, it's collecting data, it's sending data saying, okay, we hit this assert, and then we're going to report this assert to a server for someone to look at and possibly fix. Um, there's a lot of different test results that go into these scripts. So if the game works good, it does like a pass, a success result. But if the game crashes, so like if you've ever played an Xbox game and it just goes right back to the Xbox dashboard, and you're like, well, why did the game just end? That's typically a crash where the game just ends immediately. Um, so there's that. There's hangs where like you're playing the game and the game just freezes, and you have to like press the guide button and then exit it. Those are either hangs or deadlocks. Or if you're playing online and the game just says, "Oh, server is disconnected," and you look at your internet and you're like, "Well, my internet was fine. It must have been something with the game that caused the game to desync or disconnect." And so there's a lot of different failure types, and for a lot of this stuff, we have databases that hold all of these results, then web pages or some kind of UI that help people look at these results so they know, okay, I see this crash happened. I need to fix this crash. And so all of these are things I've worked on where it's just kind of the different pieces of tech that help people to understand the stability of the game. Video recording is something else where kind of like Twitch, where you're watching the game um, without looking at the actual monitor that's plugged into the kit. That's definitely useful because then you don't have to, if you want to see like, oh, what does a safety look like? Like in football, you go back in the end zone, you get sacked in the end zone, it's a safety. Sometimes you want to see what that looks like in the game, but it's time consuming to load up the game, load into the match, get in that position. With video recording, we have a lot of hours of video recording, and when the game plays itself, we record videos, and so you can search for little clips like that and be able to see that without having to load up the game yourself. So kind of easier ways to see what's going on in the game. Um, Bug tracking is another tool. So because there's so many bugs, you typically at these game companies you have some kind of like ticket or something that says like this is the bug, and then you assign that bug to QA to see is the bug fixed. You assign the bug to the developer to actually write the code to fix the bug, and so you have these bugs moving. You have these bug tickets moving through these different states, and these bug tickets. Um, it's useful if they have a lot of information on them. So if the bug ticket just says, "Oh, the game crashes," then that's going to be hard for the developer to fix. But if the bug ticket says you load into play now and you play the Falcons against the Eagles And if you load this specific stadium, then the game crashes 100% of the time. So like if you put a bunch of information on the bug ticket, it makes fixing that bug easier because then you can look at the code for that specific case. Then you can reproduce the issue and debug the game and really understand why that crash is happening. And so a lot of times we need a lot of data and a lot of information. And so sometimes people manually put that information on the ticket, but there's also ways to automatically put that information on the ticket. And so tools to automate putting that information on the tickets. Telemetry metrics is another thing. So I talked about data. Telemetry metrics is that data. So saying what the user is doing in the game. So just logs and information that says how the user is playing the game. Um, we need a lot of databases to store that, and then ways to link that game session to the ticket to be able to really understand when that issue occurred. One thing to note too is with all these tools is that a lot of times there's stuff that we game developers write, but then there's also things that like Sony or Microsoft write as well. And then there's also things that are just tools that are developed outside of the game industry that we use as well. So a lot of times at EA, the engineers here are kind of the glue to connect all of that together to put together something that is useful for the game that we're working on. So for example, like for like Sony, like that the way to reboot a PlayStation 4 programmatically isn't something we had to write. They provided us with a tool that lets us do that. But if we want a web page that lets you do that, or if we need to deploy a Madden build and then reboot it, like we have to write that code that connects all those dots to get it working. Within these games that we ship, we have what's called a product lifecycle. And so we go through these different stages of the game up until when the game is launched. So this diagram on the right I just found online, but it kind of briefly shows what it is. So pre-production is kind of when they're coming up with what features we should add in the next game. So saying like, okay, like for example, with college football, we were like, one of the years we were saying, okay, we should add high school into the game. So before you go to the college football route, you start with the high school experience. And so coming up with those designs and writing down what should happen with um, and documentation and game design docs and mock screenshots are a lot of pre-production. And then production is when they take that documentation, give it to the developers, and they say, okay, write the code to actually implement that. Once all that code's written, then you really need to test it to make sure that that code's working as intended. So that's what the quality assurance stage is. And then once it's all ready to go, then you ship the game. For Madden and College, they come out once a year. So some games take, 3 or 4 years to develop. Because football seasons are once a year, it's, advantageous to release the game alongside that football season. And so we typically have a 1 year development cycle for each of these games. But sometimes, like even as we're shipping one game, we're already working on next year's game. And so even though we see this diagram, it's a lot more complex than that, where like a lot of times everything that we see here is all year round. We're launching patches throughout the year, we're testing the game throughout the year. We're for the features, we do try to lock up the features too close to ship, but even sometimes we release new features and patches. And so it gets a lot more complicated in the real world. But that's kind of what it looks like for American football games, is kind of doing this using it based off of a calendar year because the game ships once a year. To help with that, we kind of have two different categories of tools. We have dev tools and then production tools. So for dev tools, what we're looking at is the internal versions of the game. So a lot of times if you have, let's say, 100 developers, they're all checking in new changes every day. So you have hundreds of changes coming in, and these development tools, they really try to make sure that those changes all work together and test it before those changes get released to the public. For prod tools, it's looking at data from retail users playing the game, people that bought the game, that downloaded it, that running it. Production tools help understand what those users are doing or help deliver content to those users. So like for Madden and a lot of sports games, they have Ultimate Team. So those are little pieces of content that we can update without needing a patch. We just update stuff on the server, and then you see new players or new modes in Ultimate Team. And so production tools help with that workflow. Um, and so in that sense, the difference is that for dev tools, you're looking at lots of changes just because we have these big development teams, big changes. People are working on all these different things. For production, typically, like for games, we don't release a new patch every day. Maybe it's once a month or so. Maybe sometimes there are critical patches. If there is a really bad bug, we have to release it quicker. Um, but it's different amounts of data. For production, um, for Madden, you get, millions of people playing the game, so that's millions of data points to look at. For development, we don't have millions of employees testing the game. We have, maybe hundreds or thousands. And so it's a lot less data that's being generated. And also too, that when we're running on these internal versions of the game, we typically can run on these debug builds. And so like in Visual Studio, you have debug mode and release mode. Um, if you run in release mode, you get less data and less information in the binaries. And so in production, you're running in something similar to release, what we call retail mode, and you have very little data compared to in development, where we can write out a lot more logs and a lot more information as the game's running. But as far as busy season, um, for tools, it's actually kind of quiet as the game's about to launch. That's because a lot of times the focus for the teams aren't really to get new tools. It's really to use what tools they already have to kind of focus on making sure that the game is actually stable and ready to go around launch time. So for me, launch time's kind of quiet. But then during pre-production is when it's usually busy for tools. That's where where game devs are saying, okay, we need these new tools for these new features. And so we're bouncing off ideas to figure out what tools they want for the development um, cycle that they're about to ship. And so for me, it's busier around late winter, like January, February. Um, so what else do we have here? So next up, I have this is an example of one project that I worked on within EA. So one tool. Um, so a lot of times I work on NFL, college football. Those are those acronyms there. But for a period of time, I was working on all the sports titles. So FC, that's, FIFA, soccer, UFC. So there's all these different sports titles. And so those FC, UFC, NHL are primarily developed in Vancouver, and NFL, college football are developed in Orlando. And so because they're developed in different studios, you kind of have different teams, and you kind of have a little bit of siloed approach where they're developing similar tools for similar features, but there's not as much collaboration going on. So when I first started at EA, a lot of times we would share out these tools, be like, hey, look, we're working on this one tool. And then this other team would be like, oh, we're working on like the exact same tool. And it would be hard to collaborate because when you got into the details, there were little differences. And so like kind of the company wasn't organized really to have those central teams yet. We kind of had to pull people out of the game teams and put them on the central teams to force them to write um, tech once to be shared by both the tools. And so one project I worked on was for this automation system where there was lots of components to it, a target management system, a scheduler, a task executor, and in each of the studios, they kind of did things differently, but then they had better pieces of tech in each of those components. So like for Orlando, they had a really good target management system, but for Vancouver, they had a really good scheduler system. And so what I worked on was something that took the best pieces of both of them and then integrated them together. And so all of the titles could use the exact same tool. And so we didn't need tool developers in two different spots working on the same thing. We just needed one developer working on stuff for everyone. It obviously was harder because we're listening to a lot more customers. Instead of only listening to Orlando, you have to listen to Orlando and Vancouver, listen to the requests, listen to the new features that are coming out of it, and kind of um, make sure the product was well-rounded enough to work for all of the games instead of only some of the games. So kind of the goal there is reducing the cost. So not having as many engineers throughout the organization, and then also feature improvement. So kind of giving because those tools are now working supported by multiple titles, you kind of have a broader product that allows them to test the game with more ways, kind of with less overhead to do that testing. So we were to develop a feature once and then get that feature used by like for example, eight different titles instead of developing the feature twice and having it only be used by those two titles. So that was one product or project I worked on. Next, I kind of just wanted to talk about what it's like at EA. So I've only worked at EA. So a lot of times people in game industry, they jump around from one company to another company. There's like indie companies. EA is one of the biggest game companies out there. And so I've really only had experience at EA. But EA works on a lot of different games. And so we have the sports games, but then there's also like racing games like Need for Speed. There's the Battlefield games. There's the adventure games like the Star Wars Jedi Survivor games. So we have a big, broad amount of titles. And so with these broad amount of titles, you have more opportunities to share these pieces of tech. You have these big central teams that help it. And so I think it is fun to work on things that impact a lot of different games. So um, I definitely like that. I think one example is like the game engine. So like Unreal is used by a lot of different games. There's the Frostbite engine that EA has that some EA titles use. But it's like if you develop a fix in the Frostbite engine, then that fix is seen by a lot of different games. So you kind of see a lot of bigger impact. And so it's kind of fun to work on different problems that are more general and less specific to certain games. For EA, one thing that's fun is that I mean, I don't know about fun, but one thing that's interesting is we work in a lot of time zones. So I mentioned Vancouver, that's on the West Coast. Orlando's on the East Coast, so different time zones. We also have studios all over the world. So um, we have studios in Stockholm. We have studios in Madrid and Romania. I've had meetings with EA people in Japan. So like the time zones are very different in Japan. So it's very hard to work with that. So kind of have to get used to that. One thing I like with big companies that I've kind of noticed, not even at game companies, but even with like NCR and my other jobs in the past, was that it seems like big companies are a bit more organized than smaller companies. They have seem to have more documented processes and standards. It seems like for small companies, a lot of times if you're trying to do something, you might be the first person trying to do it in the company. At a big company, chances are someone's already done it. And so you can kind of search within these internal channels to see, okay, has someone done it? Okay, I can just do what that person's already done instead of trying to, um, you know, dig through some uncertainty new process for the first time. And so it's definitely nice having that. Um, Obviously, a lot of times when doing research, you kind of have to look, like Google stuff and look within, external docs, but then there's internal docs as well. So it's just bigger companies have bigger internal documentation, and that's definitely helpful. Um, Another thing with EA and big companies that there's lots of rules within EA. So I imagine at like a small studio, like with like a studio with just 30 employees, there's probably less specialization that happens. So people wearing lots of hats. Like at a really small company, you might just have one tools person. At EA, we have whole organizations of tools teams. We probably have like 100 or well over 100 tools engineers just at EA. So we can really focus on making really good tools. And if you're just one person, you kind of have less chance to make something robust because that's just less resources to be able to work on something, and you can't make something as complicated with a small team. It definitely is nice at a big company too, especially with the yearly title with having job stability. So like with game companies, if the game doesn't sell well and that's your only game, the game company could easily shut down. With a big company, um, EA tries to shift people around a bit more where it's like if one game doesn't do super good or maybe we're not ready to release a sequel for it, um, then a lot of times we can shift them from that one team to another team. And so instead of um, having layoffs, we kind of shift people around. Um, Definitely, we have had layoffs, and it's definitely just a reality of the industry is that um, just things are always changing. And so, but definitely it seems like having a big company, you can kind of um, have a bit more stability um, with your role. Um, but yeah. So I'm kind of coming towards the end of my presentation. So these are kind of my last thoughts. After this, we go into questions. And so I'm just going to go into some last thoughts, some takeaways from the presentation. Um, Overall, my path started with Dayton. And one thing I definitely liked about Dayton was, the computer science electives. And really, a lot of those electives open up at the level 400 thing, where you're a senior and you get to choose you what two or three electives, and there's like the computer graphics elective and all of these ones. I remember looking at the syllabus, or not the syllabus, but looking at all the electives that were available, and some of them are only offered like once a year or not every semester. So I definitely say look at all of them and try to take as many as you can because those really showed the different areas of software engineering. So um, you know, tools isn't for everyone. Maybe some people want to get into graphics, but really the best way you can see those different areas, and if you're a good fit for those areas, is by taking those 400 level classes. Um, Next bullet point is kind of saying, it is hard to get into the game industry, and so I'd say treat every job as a stepping stone, kind of like a ladder, where every job should be an advancement. So you're learning more. You don't want to set goals that are too hard. You kind of just want to keep building up your knowledge and keep making yourself a more attractive candidate. You don't want to ever settle in a company where you're not learning anything new. Ideally, every day you should be learning something new, and you should be um, challenging yourself, and just to kind of make yourself a better engineer. So I'd say like try to never settle and just try to always be soaking in as much as you can. And if you ever just get complacent in a job, then trying to either look for another job or look for another role within your company, or look how you can change your current job to do something different. Um, so when I started at Dayton, we were using what Visual Studio 2008, and so these roles are very different than what it's been in the past. And so AI is, I don't know how it works at Dayton, but it's probably very easy to like do things through AI for classes, or even to think that you can use AI as like a crutch where if you want the answer, you can kind of use AI to plug stuff in to kind of more easily get the answer. Um, what I'd say, like for me, I'm more of a senior engineer than entry level engineers, and I've seen entry level engineers really use AI, and they're always optimistic. They're like, "Oh, I can start changing a lot more code, and I can do these tickets a lot faster." And some of the issues we run into is they don't really understand what the AI is doing, and so they're like, "Well, it looks like it works, so AI said it works, so I'm just gonna you know, go with it." And then when we really look at it, we're like, okay, this ran into all these issues, and AI did this really well, but it doesn't really fit together with all this other stuff. So it ends up causing a lot of issues. And so what we're really trying to make sure is that, we definitely want to use AI, but we want to understand what it's doing. And we want to add that ownership of AI. So like even if AI generated some code for you, definitely understand what it's doing and make sure that it makes sense. Like you never just want to just take it for granted and then just do it. You really want to look at every line of code that it's doing. And a lot of times it's you have to groom the data it gets back. And so um, if you're using Copilot in Visual Studio, I don't know if those are actually have licenses for students, but just if you're using it, just try to make sure you're understanding it because like the reality of the industry, software engineering industry is it's probably going to be transformed and be a lot more AI in the future. And I think that's fine, but just make sure you really understand what it's doing because you wouldn't want to, you know, break a lot of things because you're rushing with AI. And so, um, like you're always going to need senior engineers anyway. And so, it's beneficial to learn what it's doing anyway. last bullet point is just team projects. So this was almost one of the best things with my business leadership undergrad was that in the business classes, there's a ton of team projects. And in computer science classes, there's maybe like one or two classes that we had like big team projects. But those are really great just because that really shows what software engineering at a company is really like. Even if you're on a small game company or a small software team, you're still on a team. Like it's very rare that you're working in a bubble. So things like merging two engineers' changes together, that's a very common thing. And so trying to get as much of that experience as possible. Learning to read other engineers' code to say like, hey, I think your code's confusing, or I need to help understand what your code's doing. Like it's very beneficial to read other engineers' code just because you're probably going to join a company that already has a lot of code. And even if you write a bunch of code, they might hire other people that write code too, and you might be doing code reviews. So you need to be very good at working with other people. And so team projects can help that. But that's all I got. So hopefully some of this stuff was interesting. I still have, maybe 10 minutes or so before I gotta go, but I am definitely open for questions if people would just want to ask anything about me, the game industry. I don't speak on behalf of EA, um, I'm just an employee that works there. Okay, so I can't, talk about any like secret projects or anything, but I can definitely tell you, what I'm allowed to talk about. But thanks everyone for listening, and I'll hand it back over to Ryan to see if there's questions or anything. Yeah.
Awesome. Thank you, Peter. Okay, we're going to take some questions now. If you guys have a question for Peter, please raise your hand and we'll come around with the mic.
Thank you. So my question is for those who are interested in getting into the video game industry as a whole. I'm personally interested in like the gameplay and game design and development aspect. What are the best things to do individually with like maybe your free time or anything like that to really have your best shot into getting into the industry?
Yeah. So um, for gameplay, I'd say so like one thing that's definitely useful is like having a little side project. So like for gameplay, trying to understand all of these little tweaks you can do within a game and what those effects have with those tweaks. And you kind of understand that the most if you have a side project. So whether you're building like your own little board game, I'd say that's definitely um, beneficial, like documenting rules, documenting like things like that. And then also like side projects where um, a lot of times they have, I wouldn't say mods, but like either software that helps you build a game yourself. So like it not necessarily write code, but little things that you can kind of, I know like in the past there was like old like RPG makers, um, you know, trying to build your own games so you can say like you worked on this project. And if you work on them by yourself, that's good, but working on them with other people as well. Um, because it's gameplay, you don't want to get too stuck in the code. You definitely want to try to, if you're trying to get into game design, you want to try to focus on that game design element. So, um, like for Madden, like you know, a lot of times you have to like document these things and build these big guides that say like this is like a mock screenshot. This is, how this feature would work and kind of documenting everything. So trying to get as much experience with that. And then definitely like whether you're doing it through a board game, whether you're doing it through some kind of tool that lets you do it, or even if you're using like a free license to Unreal Engine or Unity, like if you actually build something, that's definitely attractive. I do know like game design jobs are definitely, it feels like those are even harder than software engineer jobs in the game industry to get, just because on the surface level, it's very attractive. It's like, okay, um, you're tweaking, you're actually building the game, but there is a lot of work that goes into it, and a lot of like rules and processes. So trying to get as much of that experience as possible is what I'd recommend.
Thank you. All right. Any other questions for Peter?
I just want to get a little bit more about your like interview process at EA. I feel like what it was like at a big company like that, time and
Yeah, that's a
rounds.
good
Did they
question.
help with
So
like relocation too?
yes, so for pretty much every game company, they have you can go to like EA.com and then they have like oh jobs, so jobs.ea.com. And so um and I remember doing this when I was searching for jobs was going to all of the game companies. So you just kind of Google the game company you're interested in, going to the jobs website, and then they have the job on there. I know there's things like jobs on LinkedIn, jobs on Indeed. Like for me, I like going straight to the source, going straight to the game company's webpage and looking at the jobs there. So that's what I did, and that's how I applied, so just going to the job. And a lot of times, these rules are changed. These jobs are coming up and then coming down. So you kind of have to look at the jobs a lot. So if you're really interested in one company, like looking at that jobs list on the web page like once a week just to see what jobs are being posted and taking down. Game companies typically get a lot of applicants, and so you do have to make sure that you're applying for something that makes sense to you. Like if it says you need 5 years of experience and you don't have any experience, then it might not be worth applying to that one. But if it says you need, you know, 1 year of experience and you have 1 year of experience, then definitely applying to that one. So starting with that and then going to a phone interview. Um, so typically, like the phone interview is set up through like an email where they'll email back and say like, "Oh, um, you know, we saw your resume. It looked good. Would you be available to chat?" And so I've done a little bit of that hiring in EA where it's like I'm on the inside and I have it. I talk with people that are trying to get a job, and so um, that there might be multiple phone interviews. And then I think I haven't been too involved with like the following steps. I know like if you live in the city, typically we'll ask you out for an on-site interview. That's what happened for me. I lived in Orlando and I just drove to the studio for the on-site interview. I had the one, maybe it was two phone interviews and then the on-site interview and then the offer. Um, but some people have multiple on-site interviews. I think as far as like flying people out for the on-site interviews, they might only do that if you have like a ton of experience, in the industry. And so, um, so they're definitely looking at people that are able to do, um, can actually live in the location of the studio. I know during COVID there was a lot more remote roles, but kind of the whole tech industry, like Google and whatnot, a lot of companies are kind of doing less remote and kind of trying to have more people come back into the offices. And so it's not super realistic to think that you could like work remote, like entry level for a game company out of a city that's not where the studio is located. And so, um, but really just phone interview, in-person interview. The phone interview is kind of chatting about your roles and your resume, and really at the in-person interview sometimes you have like a little test where like you kind of have to do the test in front of them and then talk through the answers. Like we did a little bit of whiteboarding where like someone wrote some kind of question on a whiteboard and then I tried to show my thought process on how to solve it. Um, but that's kind of what it looked like, but definitely having like a good up-to-date um, resume. And then when you apply on the web page, typically you still have to put information on the web page. I'm a big fan of LinkedIn as well. So having like a really good LinkedIn profile, and then you can attach that LinkedIn profile on your resume. So it's easy to access from a web page as well. But yeah.
Okay, I think we have time for one more question. If anyone else has a question.
Awesome. So you were talking about those 400 level electives as being your favorite when you were at UD. Can you talk about the foundational courses and their importance that allowed you to appreciate those courses that were available later on, and which ones were your favorite that you would like to see brought back?
Oh yeah. So the foundational ones are definitely important, like the 150, 151. Like for me, um, when I was in high school, I did some kind of programming on like, remember the TI-83 calculator? So like wrote little programs on that. So I never really had like good C++, C# experience. And so in those 151s is when I got that C++, C# experience for the first time. And so being able to like actually use Visual Studio to write code. So I don't know what programming languages you guys use at UD now, but like that's 150s were my first dose of like a real programming language on a PC. You write some code, you press F5, it compiles and runs. So that's very highly critical. And so um, it's useful because it's for people that have been coding their whole lives and then they're doing it, um, you know, it's kind of your first like professional organized way of doing it. Some people might have been doing it their own way, kind of Googling, but kind of doing it in a classroom setting is important. And for people that haven't been coding their whole lives, then this is their first introduction to code. And so I think it will help you understand if coding is right for you. Like if you really struggle with the 150s or you're just don't like having to do all that research to program, maybe it's a sign to kind of consider switching majors. For me, you know, I do remember a lot of times like with those 150 classes, there was like the homework's due the next day, and I was up late at night trying to get this stuff to work, and I was Googling stuff, and it said, okay, try this, and I tried it in the code and everything broke, and then I Googled something else and I tried another thing. And so that whole process was definitely very frustrating, and it made me think like, is the software industry like this? And to an extent it is. But some of that, it definitely comes easier the more you learn. And you can never really, you know, get to that advanced level by not, um, you know, um, getting through it. You kind of have to make it through the hard parts to get to the easy parts. And so you definitely have to experience that. And um, even if 150, CPS 150 and 151 are easy for you, there's so much in programming and so many advanced theories and models and stuff. And so there's definitely a lot to learn within programming. And so, um, yeah, the 150s are definitely interesting. Just everything starts to make more sense the more you learn about it.
Awesome. Well, thank you so much,
do have,
Peter. It's been
I do have
awesome
time
having you.
for another one if you do. If
Oh,
there are
yeah,
more
sure.
stuff.
Do we have one more question? If not, I can ask a question.
Yeah. Yeah, so you mentioned sometimes that developers act as kind of the glue between the entire stack between, Madden and like the embedded platform, like your PS5 or your Xbox. Um, where does QA draw the line on like, okay, we can tackle this bug, or like this bug needs to be escalated to like another service or another development team outside of, what we can handle in-house?
Yeah, that's a good question. So, I think one thing is like for QA, you know, they want to report as much as they can. But like, for example, if QA finds an issue, they report it, and typically some kind of senior person will try to move it to the right bucket. And so a lot of times that's what the product manager does is they try to help assist and say like, okay, I know this looks like an online issue, so I'm going to send it to the online team. Or they'll say like, oh, this is just actually like Xbox Live was down, and we don't actually have to do anything on our side because that's more of an Xbox problem. And so you definitely have a lot of times it comes from just experience and seniority to know like where the actual root problem is. And so um, there's always so many problems and so many things. It's like we can't fix everything. We just kind of have to, you know, look at it and point it to the right bucket, to the right area, to the right owner, to the person. And sometimes you send it to the graphics team, they look at it and they're like, oh, this isn't actually a graphics issue. This is actually a gameplay issue. And so sometimes those bugs do move around. It's just when they do move around, you try to attach as much information and they try to provide that justification to say, like, oh, this is not a graphics issue because of XYZ. And so if you write that down, then, the people reading that can learn from that and kind of build up that knowledge. So there is a good bit of finding who's the right person to go to for a lot of these problems. But So yeah.
Awesome. Thank you so much, Peter. It's been great having you.